Okay, hello everyone. So let's talk about the Lab8 amplifiers. Okay, so uh, generally we have two kind of usually we have two kind of amplifier, inverting amplifier and non-inverting amplifier. And first of all, I want to talk about what's the function of amplifier. So for example, the inverting amplifier. Like this is a circuit diagram. So uh, let's say we have a like 0.1 volt sine wave input, something like this, and the signal after the amplifier, the signal will be amplified. So it will be something like this. Okay, and the reason we call it inverting amplifier, you see, because the output will have a 118-degree phase shift. So that's why we call inverting amplifier. And the gain for this amplifier is controlled by these two resistors. Okay, so for example, if the gain, let's say the ratio between these two resistors is 5, so the 0.1 volt input after the amplifier circuit, the output will be 0.5 volt amplitude. Okay, so that's the function of amplifier. And similarly, if we have a small like 0.1 volt small sine wave, the non-inverting amplifier will also amplify the signal. But since it's called non-inverting amplifier, we know there is no phase shift. Okay, and the gain equation is here. So 1 plus R2 over R1. So that's a gain for this kind of amplifier. So overall, the function of amplifier is just amplify the signal. All right. So let's see. So for task one, remember you have two tasks for your pre-lab. Okay. So for task one, you're going to build a non-inverting amplifier by using LM324N. So you will let's see, LM324. So I think you already check this data sheet. Okay, so in the pre-lab. So LM324 is something looks like this. Okay, it's a 14-pin chip, and the pin layout looks like this. Okay, so so this is a pin layout, and for each LM324 chip, there are 4 amplifiers. Okay, so 1, 2, 3, 4. Each amplifier, they are not connected to each other. So for example, for task 1, you're going to build a non-inverting amplifier. If you decide to use this amplifier, you always use this one. Okay, so for example, if you choose pin 2 and pin 3 as your input, the pin 1 will be your output. Okay, so you cannot use pin 7 as your output. They are not connected to each other. Okay, so let's say I can show you how to build the circuit. Okay, so let's start from input. So input, you will have input, you will have a 0.1 volt, 1 kilohertz sine wave. So that will be generate from W1, okay, the function generator. So the W1 will connect to the positive input. Okay, so let's say we decide to use this as your amplifier. So the positive input is pin 3. Okay, so which means W1 connect to pin 3. Okay, so this part is done. Then we start to build the resistor. Okay, so R1. So one side of the resistor is connected to ground. Okay, so R1 one side to connect to ground. Another side of the R1 connect to negative input. So if you check the pin layout, pin 2 is a negative input. So another side of R1 go to pin 2. And then we can continue with R2. Okay, so for R2, one side of R2 connect to negative input, which is pin 2. Okay, then another side of R2 is connect to output. Okay, so that's pin 1. So pin 1 is the output you see here. So that's pin 1. Okay, and then the output, you can use oscilloscope to detect the output. So you can connect 1 plus to pin 1. And the last step is you don't want to forget to connect the power supply. Okay, so for example, if you check the data sheet, pin 4 and pin 11, that's the power supply, and the pin 4 is the positive power supply. So that's the pin here. So the positive 5 volt connect to pin 4, and the positive 5 volt is come from the V plus pin. Okay, so that's the power supply of your AD2. Okay, so pin 4 connect to V plus of your AD2. And then the pin 11 is the negative power supply. Although it's labeled, let's say it's labeled ground, but you don't need to connect to ground. Since you see here, this is connect to negative 5 volt. So what you will need to do is connect pin 11 to V minus. Okay, the V minus provide negative 5 volt. Okay, so and before you build the circuit, you make sure you check the direction. Okay, so this little marker, or so if you check the picture here, so there's a little half square stuff. So this indicates the direction. Okay, so you see here. So don't make sure your circuit is at the right direction before you build the circuit. Okay, so yeah, and the reason you don't want to inverse your chip or make sure your direction is correct is if you put pin 4 connect to negative power supply, pin 11 connect to positive power supply, it may break your chip. Okay, so double check your circuit before you turn on your power supply. Make sure pin 4 connect to V plus, pin 11 connect to V minus or ground. Okay, so and one thing you need to know is, so you see here, you need to pick up all the resistance that's greater than 1 kHz, 1 k ohm. So that's this is required not only for this task, also for this today's whole lab. All the resistor you're going to use, like even in the task 2, all the resistor need to at least 1 k ohm. Okay, so yeah, I think that's task 1. So after you build the circuit, you use a scoop to check the input and output. Okay, so and take a screenshot. Okay, I think the task 1 is simple. Then you're going to do the task 2. Okay, so the task 2, you already calculated the value in the pre-lab, right? So question 2 of task 1 in pre-lab is about this circuit. Okay, so but I think in task 1, in pre-lab, you can use whatever value you want as long as it satisfies the requirement here. Okay, but for this task in the lab, you want to make sure the value you are going to use for the resistor and the capacitor, you have those values in the lab kit. Okay, so for example, if you choose R1 as 1 ohm, R2 as 10 ohm, that's fine in the pre-lab, but in the experiment, you need to make sure all the resistor at least 1 k ohm resist. Okay, and also for capacitor, you only have limited capacitor in your lab kit. Okay, so yeah, task 2. Firstly, you want to make sure you do the calculation. Okay, so you need to use those equation. Okay, so for example, R1 and state 1, so these two components control the is working like a filter, so control the input signal frequency, and the R2 and R1 control the gain of the amplifier, and R3, R4 control the offset or the common mode voltage of the output, and the C2 working with R3, R4 control the charging time. Okay, so you will use those equations to calculate the value for each component. And my suggestion is that you want to choose the capacitor first, okay, because you only have limited capacitor in your lab kit. Okay, so for example, you want to fix the capacitor value, then calculate the resistor value. Okay, so after you do the calculation and pick up the components, you can start to build the circuit. And the one thing you want to make sure here, the R3 is directly connected to R4. Okay, so R3 is not connected to R1. You see here, they are not connected to each other. So that's a common mistake student made before. So R3 directly go to R4. All right, and then if you check the question 2, it's asking to apply a reasonable weigh-in based on the expected gain. So what's that mean is, so if you remember in pre-lab, it's required the gain of this amplifier to be -10. So, and if you check the datasheet for the LM324, there is a requirement that the output voltage swing, so it's is right here. So the output voltage swing is from 0 volt to V plus, that's the positive power supply, minus 1.5. So which means that's the output voltage range. Okay, so when we apply to this circuit, the VCC is 1.5 volt, and the VSS is ground, so that's 0 volt. So which means the output swing is from 0 to 3.5 volt. Okay, so that's the maximum output voltage. Okay, so the range is limited in this two value. Okay, so then you need to think about the gain is 10. So if you choose your input voltage to be 1 volt, the output will be -10 volt. This voltage exists this range, okay, exists this range. So you want to make sure your input voltage kind of small, so your output does not over this range, okay? So that's question 2. And then question 4, compute the AC and the DC value. So I mean percent error of the AC and DC value. What's that asking is the DC value is the output average value. Okay, so if you remember, because the R3 and R4, the output voltage is controlled by the DC voltage in here, and ideally it will be 2.5 volt. And you need to verify it by measure the output average value. And the AC value is simply just the gain. Okay, so you want to make sure your gain is around -10. Okay, so yeah, that's task 3, I think. Okay, yeah, that's task 3, and then you can follow the instruction to next step 5 and step 6. Okay, for task 3, I mean that's task 2. For task 3, you're going to build 2 comparator. Okay, so LM339, that's a comparator, and you're going to build a comparator by using op amp. So LM324, that's an op amp but you will use it as a comparator here. So one thing here, the 10K ohm resistor is the potentiometer. So this pin is the output. So that's corresponding to the middle pin of the potentiometer. Okay, let's see here. So if you see the question 2, you're going to generate a triangle wave that from 0 volt to VCC, and VCC is 5 volt here. So which means the triangle wave should start from 0 and end at 5 volt. So if you want to generate this kind of signal from start from 0 to 5, you want to make sure you have an offset. Okay, so something like this. Okay, you need to have an offset so your triangle wave can start from 0 and at 5 volt. Okay, so yeah, so then you're going to build this circuit. All right, so make sure you check the data sheet for LM339 for the pin layout. The pin layout is different from this LM324. Okay, so the question 3 is asking to capture some screenshot. So since you are using AD2, you cannot capture all those input and output together. So you can have 2 screenshots. Okay, so first screenshot, you have input. So the input is the triangle wave, and the output of op amp. So input triangle wave and the output of op amp. And then you can have another screenshot with the input and output of comparator. Okay, so you can take 2 screenshots instead of 1 screenshot. We include our signal. Okay, so yeah, before I end this task, I will also want to talk about how comparator works. Okay, so hopefully you already read through the manual and you should already know how comparator works, but I will also go through it really quick. So basically, this is a comparator. You can use the op amp to build a comparator, and the comparator is comparing the 2 input. Okay, the positive input and the negative input. They are comparing all the time. So when the positive input is greater than the negative input, the output will be VCC. Okay, so positive power supply. When the positive input smaller than negative input, the output will be VSS. Okay, in here it will be 0 volt. So this graph, let's say this example. So the V plus will be a DC signal, so it's like a straight line, and the V minus is a triangle wave. Okay, so this is the V minus. So for this range, okay, so for this period, V plus is greater than V minus, so which satisfies this requirement, then the output will be VCC. So this is VCC. And then for this period here, V plus is smaller than V minus. Okay, V plus smaller than V minus. Then the output will be VSS. Okay, it's low, and then it repeat again. Okay, so yeah, I think that's task 3, and I think this lab is not too hard, but the hard point for this lab is build the circuit. Okay, so when you build a circuit, be careful, and you want to make sure your connection is correct, and you might want to double check your circuit before you turn on your power supply. Yeah, I think that's it for this week, and yeah, just let me know if you have any question. And remember we have office hour, so you can attend the office hour online if you have any questions.